Welcome on the behalf of Sri Siddheshwar Devasthan, Sri Siddheshwar Women's College of Engineering, Solapur, the convener of this FDP, our principal, Dr. T. A. Chavan, and the myself, coordinator, Dr. Avinash Patil, co-coordinator, Dr. S. J. Madki, all the organizing committee, our all helping hands from the IT section, and all the participants. Welcome all of you in this last session. As a part of our session, I take privilege to introduce today's speaker, Dr. Anil Ghanwat. He's a currently associate professor in School of Chemical Science, Punyashlok Ahilyabai Holkar, Solapur University, Solapur. He has completed MSc, MPhil, and PhD. He's having 25 years of teaching experience and administration experience in University Department of Solapur University and the PG Center of Shivaji University at Solapur. His area of specialization is polymer chemistry. He has published 64 international journal publications in international journals and 72 conference presentations. Under his guidance, 10 students have completed PhD and many more are in pipeline. They are working with Sir. And he has guided more than 70 PG students for their projects. His active participation in development of Department of Chemistry, Shivaji University Postgraduate Center, Solapur University campus since inception of Solapur University. Current research interest is controlled radical polymerization, high performance polymer, polymeric materials, nanomaterials, nanocomposites, organic chemistry, organometallic chemistry, gas sensing materials, conducting polymer sensor, thin film deposition, etc. He has completed two research projects funded by University Grant Commission as a major research project and project under RUSA also. He has also attended one conference at South Korea. He has worked as a director of chemical sciences, head of the department of the polymer chemistry. He has worked as a coordinator of the instrumentation center USIC at Solapur University. He's also coordinator of boys and girls hostel. Worked as a member of management council, member of senate, member of academic council, chairman of the board of studies in chemistry, IQAC member, secretary, NAC steering committee at Solapur University. He has also examined the PhD Viva as a referee under Pune University, SRTM University Nanded, and KBCNM University Jalgaon, Shivaji University Kolhapur. He's also worked as a resource person and chaired the sessions in the seminar, conference, and workshops. He's a life member of the Society of Polymer Science. As a subject expert on the selection committee for selection of lecturers in colleges, affiliated colleges, nominee of the vice chancellor. He's also worked as a nominee of vice chancellor in the selection committee of LIC, PhD admission committee and all that. He was the organizing secretary of many of the activities held under Solapur University. So many more to tell about him. So with this vast experience of 25 years and versatile personality, Dr. Anil Ghanwat, I come from the organizing side. Welcome, sir, and thank you for accepting our invitation. And I request you to proceed for your presentation.
Thank you, Dr. Avinash Patil, sir. First of all, I must thankful to the Siddheshwar Women's College of Engineering, Solapur, for giving me an opportunity to give the talk in this online faculty development program. I should thank to the convener, the principal of the college, Chavan sir, my good friend Dr. Avinash Patil sir, Madki sir, R&D co-coordinator Chavan sir, all the teaching faculty, non-teaching faculties that are involved in successfully running this faculty development program. And I, being from the Punyashlok Ahilji Holkar Solapur University, I also welcome all the participants in the Solapur. The Siddheshwar Women's College of Engineering is one of the best engineering college we have in the Solapur, and that you must have experienced in last 6 days as you are coming to the end on the last day. So the organization, the students, they are very satisfied here, and I wish to start with the talk as I have gone through the different topics covered by the different speakers in the earlier lectures. So today I restrict myself to the advanced polymer materials. Again, within the advanced polymer materials, there are many more materials, but again, I will give the glimpses of the some of the materials, and I will also explain the materials that I have synthesized in my laboratory with the help of my research students, again with the fundings from the various funding agencies. So whenever the students feel anything, they can interrupt me in between, or we can have the question answers at the end. So we'll start with the advanced polymer materials. So you all have the aware about the polymers. So I inquired with the organizing committee, and they told that all the speakers, all those participants are from the different faculties, and they have the idea about the everything. So for the polymers, just briefly, I will give the idea what actually the polymers are, and then I will go with these topics. So you know all the monomers, those are the small molecules, and then we are going for the macromolecule that we know as a giant molecule, big molecule, or the high molecular weight chain. So these polymers have make the very big revolution in the world, because we know the Stone Age, Metal Age, the fourth, the basic thing or the revolution happened in the world is the polymer age, because right from the morning to the evening, everywhere we use the polymer, and as because of the help of this technology, we could able to change the transfer the life of the society to make it the easy, because we all know the research that should be end into the help of the society, the people of the society, and if they all get helpful, then only the research has the meaning. Otherwise, the research will goes into the only publication and the presentation. So whatever the research we are doing, that should be commercialized, and then it should have some advanced applications. That is what actually we should look for. You all, being the chemistry peoples, all are known hydrocarbons, because chemistry is nothing but the carbon, hydrogen, and those things. So you all knows up to the carbon number 4, all the hydrocarbons are the gas, methane, ethane, propane, LPG, there whatever we are using. Carbon 5 to 19 are the liquid, and the 20 to up to 40 are the wax, and more than 40 if you go, then you are talking about the plastics or the polymers. So the polymers are high molecular weight compounds, as what we have seen earlier, the big polymer chain. As compared to the other compounds, the molecular weight is high for the plastics. So we know all the polymers you have listening all from last 5 days, the different topics. So polymers, that may be the natural polymers or the synthetic polymers, but those are natural polymers like cotton, silk, wool, leather. They have the limitations in the applications, they have the certain applications, but when you talk about the advanced polymers, then again they are lacking in those applications. So we have to go for the higher applications, that we are talking about the synthetic polymers. So we can have the thermoplastics or the thermosettings. Those can change the shape. When we heat it, they can become soft. When we cool it, they become hard, and we can reshape the things many times. That is what the recycling does, or thermosetting. They cannot just change the shape. So there are the certain polymers we can reuse it. Certain polymers we cannot reuse it. Once we use it, they cannot change the shape. So they are not reusable. Also, we know the polymers as a simple word, but we have the plastics, elastomers, fibers, adhesives. So all these are the polymers. All these are the plastics. So these polymers, that may be the homopolymers or they may be the copolymers. So this plastics, elastomers are those the polymers we have. So this plastic that we are talking about the hard polymer materials. Elastomers, we are talking about the rubbers. If the polymers are rubbery polymers, elastic polymers, just like elastomer, when we stretch the rubber on stretching, they will get stretched. When you remove the stress, they will come to the original position, like elastic materials. Fibers, we know the thread, when the length of the material is 100 times greater than the diameter, we call those materials as the fibers. Adhesive, the liquid sealant compounds, is based upon their behavior, actually where we use it. So accordingly, we are classifying as the plastic, elastomers, fibers, and the adhesives. So physical state, how we use it for different applications. So these are the polymers and homocopolymers. We use the simple monomer, or we can have the two monomers, three monomers, and then we are using for this polymerization. We can synthesize the polymer either by the addition polymerization, we can synthesize by the condensation polymerization. So there are again the different ways of making the polymers. Again, whatever the polymers we are talking about, so those polymers may be again from the linear type, branched type, cross-linked types, or the network type. So advanced polymers, whatever we are going to discuss later on. So few polymers among these will be the linear type, means they have the simple structure, straight line type of the structures. Again, the conformation will be different, configuration will be different, but they have the no side branches. If the branches are there, we call it the branched polymers, and the thermostatics are cross-linked. So the polymer chains are interlinked, and because the polymer chains are interlinked, so they are become cross-linked types, and because of this, we cannot change the shape. Actually, we have talked thermostatic and thermoplastic. So first two are about the thermoplastic. The cross-linked polymers are network polymer. They form the three-dimensional giant molecule that is we have shown in the picture. Right side, you can see that their chains has been joining together, and because of that, they cannot change the shape.
तिथपर्यंत पोहोचलो ना
Next,
आपण पुढचं गेलं म्हणायचं.
is it visible?
Yes, visible. Just you
Okay,
make
okay,
a
okay.
can that tagline you can make hide option is
Okay.
there. Sharing,
Yes, yes,
stop
yes.
sharing.
Hide it.
Just
Yes,
do
yes.
that.
Hide. I have hide. I have hide it. Okay, 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 okay. One of the interesting fact for the all the faculty members, those are the polymer chemistry background, they can know. But this is a some unique picture you can see here is a collection of the latex from the rubber tree. We know the Hevea branchylica tree. We are using the natural rubber, and that rubber is a natural polymer that we are getting from the trees. So when we cut the bark of the tree, by cutting the bark of the tree, there is a collection of the latex, and the small pots are hanged on the tree. And with hanging the small pots, we collect the latex. And once we collect the latex, then it gets coagulated and then form the rubber. So we are using for the different applications like the tires or the shoes or those things. And vulcanization, that is a cross-linking process. That is what generally the you all are aware about the when the vehicle get puncture, how to do remove the puncture. That is simple process that called as vulcanization. The person who remove the puncture, he apply the liquid and then he stick the two rubber part together. So whatever the liquid he is applying is the sulfur. That is what is shown in the reaction sulfur. Polyisoprene is actually the chemical name of the natural rubber. So when you apply the sulfur liquid and when we put it for some period of the time, the sulfur form the linkage in between. And again, you have the idea earlier nowadays because of the radial tire or the tubeless tires, directly is applying the solution and we can fill the air. So that what the solution is, that is what the sulfur, that is what the chemical reaction. The cross-linking in rubber chemistry we call it as a vulcanization. That is what for this one. So this is what we do for this one. So next we know the most common use the plastic and which create the problem nowadays in the environment is the polyethylene, because everywhere we can talk about the pollution of the plastics and the problem relating to this one. So that all the problems are relating with this polyethylene. So polyethylene polymer, high low density polyethylene and high density polyethylene. So mostly it is used for the packaging purpose, and everywhere it form in the using for the carrying the materials, people throw in the environment, and that clog the rivers, pipes, everything, and it create the problem. But this polymer is one of the most used plastic in the world. Polyethylene, then polypropylene, then PVC, and the polystyrene. That is what the sequence goes on, like up to the polyethylene terephthalate. So the high molecular polyethylene, again for making the gears or the joints replacements, helmets. That is what we are using, or the PVC pipes, CDs, DVDs. Those come from the PVC or the polyethylene terephthalate. This is what we use in day-to-day life for the water bottles, soft drink bottles. This is a condensation type polymer. We are preparing this polymer by using the ethylene glycol with dimethylene terephthalate. So with the ethylene glycol and dimethylene terephthalate, so we get the polyethylene terephthalate (PET) polymer. The recyclable, so we can use the water bottles, and water bottles will almost never found any pollution because of the water bottle, because rack pickers can collect the waste of the water bottles immediately. They are not picking the polyethylene carry bags, but they can pick this one because they're getting better price for this one. And also the soft drink bottles, those are different than the water bottle. You can feel by the physical appearance also. Water bottles can easily flexible, we can press it. Soft drink bottles are hard, because in chemical language water bottles are simple, soft drink bottles are biaxially oriented. The chemical molecule insides are biaxially oriented, and they are the impermeable for the gases, because the main important parameter about the soft drink bottles, they should not permit the carbon dioxide gas from outside, and to make it hold the CO2 gas, the bottles are become more rigid, and for that they are become biaxial oriented. You all know these are the two examples of nylon and the Kevlar. So this is aliphatic polymer, nylon. Kevlar is aromatic polymer, generally used for the bulletproof jackets, because if you see the structure, benzene ring, CONH, benzene ring, CONH, only amide linkages, and those again rings are linked together by the hydrogen bonding. So they have the hydrogen bonding inside, because the structure is very very strong. So this Kevlar polymer used for making the bulletproof jackets or the bulletproof helmets, bulletproof glass. So this polymers is inserted in between for that purpose. And nylons are simple. So we are using the nylon ropes, nylon cloths. So this is aliphatic polymer made from the hexamethylene diamine with the adipic acid. So these are the simple CH2 aliphatic structure. And if you go for the aromatic structure, the material can become very hard. So these are the natural polymers. Those are proteins. There are also some inorganic polymers. So you can have the delay use the
पाटील सर. पाटील सर.
हा येस सर.
हा नाही सरांचा आवाज येत नाही का कसा आहे बघा.
हा हा एक मिनिट फोन करतो सर सरांना.
हा
घनवट सर कनेक्शन लॉस झालं का तुमचं घनवट सर.
त्यांना फोन करा त्यांचं बहुतेक रेंज किंवा कशाचा प्रॉब्लेम आहे.
सर बघतायत सर. हा सर तुमचा हे स्क्रीन शेअर करा सर. घनवट सर आवाज अनम्यूट करा सर प्लीज अनम्यूट. प्लीज अनम्यूट युअर माईक सर. हा सर
केला अनम्यूट केला.
येस येस स्क्रीन शेअर करा.
केली.
हा सर
झाले शेअर.
हा पीपीटी मोड करा सर. स्लाइड शो मोड
केला. स्लाइड शो मोल्ड केला.
स्लाइड शो हा ओके सर ओके कंटिन्यू सर. आता
इथूनच बाहेर पडलं. बाहेर कुठून पडलं.
हा साधारण याच वेळेला नाही ह्याच्यानंतर ह्याच्या पुढे गेला होता.
इथं
हे पण झालं होतं.
हा
हा येस येस
ओके ओके नो इश्यू. नाव इट इज विजिबल.
येस सर येस.
ओके ओके थँक्यू. Again, sorry for inconvenience.
नो इश्यू सर कंटिन्यू सर.
Okay. Okay, so with this background, so just I have started the why the advanced polymers are important. So the advanced polymers, so because of versatility or their high performance properties, sustainability, or the cost effectiveness, they are important. So these high performance polymers are of the different types. So when we use the high performance polymers in the research, we generally classify those polymers likewise. the thermoplastic, thermosetting polymers, elastomers, or the biodegradable polymers. So generally the polycarbonates or the polyamides, polyamides, polyazomethines, such type of the polymers we synthesize. In case of thermosetting polymers, we synthesize for the epoxy resins, phenolic polymers, polyamides. Here we cross-link the polymers, and when we cross-link the polymers, they are infusible, insoluble. They will not get melt. They will not soluble in solvent, so they will remain as such. Elastomeric applications, we generally go for the rubbery type of the materials. So those are the elastic materials. And for biodegradable, generally most commonly used the polymer is the polylactic acid, polyhydroxy alkonates, but mostly use the polylactic acid, and also we are using from the polymers from the castor oil, from the linseed oil. We also use from the cashew nut cell liquids. So those polymers also we can use for this one. So advanced polymer applications, they are generally used in the industries. So generally we use these polymers in the aerospace applications, automotive applications, medical applications, electronic applications, packaging applications. So in case of the aerospace application, what actually we required is lightweight composite polymers, and those have the high temperature materials. So we can have the just like polyether ether ketones, or have the carbon fibers composites, or we can have the different applications. We can insert the carbon nanotubes. We can have the fiber insertion in between. So we can increase the strength of the material, and by increasing the strength of the material, we can use it. Even for the automotive applications, the polymers in the lightweight, high strength material, the composite. The example, just you can have the idea, get the idea. For the aerospace applications, lightweight components and the thermal protective systems, that is what actually the polymers are used. You all aware about the launching of the PSLV vehicles and those things. When the vehicle get launched, and you can see that as it cross some distance, some polymer get melt, that fallen away. Again for the next temperature, the polymer get melt. So these polymers, this vehicle is coating with the polymers sustainable at the different temperature. So you can start from the 200, 300, 400, 500, 1000 degree centigrade temperature. So we are using the different polymers, high performance polymers for this purpose, and they can get melt at around those temperatures. Or you can have the lightweight components. So when the components are lightweights for the automotive industry, it actually make saving in the huge way, because if you compare the automobile industry in the earlier in the 80s or 90s, and if you compare with the nowadays in the 2020 or the 2010, there is a larger difference. Use of the plastic has been increased a lot. Use of the plastic, almost the metal sheet is only for the high strength metal sheet for the body, but almost all the bumpers and all those parts are from the plastic. Those are the high strength lightweight material. They can sustain the impact, but at the same time they are durable. They have the good strength. So dashboards, airbag material, so we can prepare from this material. So because of this, we can save the fuel, we can increase the duration. The coats are applied on the vehicles. Those are the advanced type of the materials. So again, for the biomedical applications, we use these polymers for the biodegradable implants or the drug delivery systems. So control the delivery by using the polymers, or we can have the hydrogels or the scaffolds in which we can put the drugs, and with the change of the pH, we can go for that one. Or the packaging industry, again we use these polymers, biodegradable sustainable materials for the packaging applications. We can have the use of the polymers for the electronics. So using the flexible electronic parts, the sensors, batteries, or the OLED displays, polymer solar cells. So we have the idea about this use of the polymers in the electronics and the LED applications. So even the liquid crystal polymers, LCPs, or the LED polymers we can have use here. So in the supercapacitors, fuel cells. So for this purpose we can have. So we can have the recyclable polymers. So we can start with the monomer, we can go for the polymerization, we can prepare the polymer, and you can go in the reverse way. So we can have the recyclable materials. So we can recycle it, and we can use for the different applications. Similarly, we use the polymer nanocomposites. So we know when the polymers are combined with the nanoscale material like carbon nanotubes, graphene, nanoparticles, that enhance the properties. In my research also, I have tried these various nanoparticles, even TiO2, ZNO. So you have the if we include the nanocomposites, nanoparticles into the polymer, and if we load the nanocomposites, the polymer shows better properties. It has the benefit to the earlier properties of the polymer without use of the nanocomposites. So they increase the strength, they increase the thermal stability, the conductivity, electrical conductivity of the polymer increases, and the flame resistance properties or the thermal stability of the polymers that get increases. So by using this various nanomaterials, we can increase the strength. So we can have the smart polymers. The smart polymers that generally responds to the external stimuli like the pH or the lights or thermoresponsive polymers, pH sensitive polymers or electroactive polymers. So we use this polymers generally for the drug delivery, self healing or those applications. So generally for the drug delivery polymers, what is done is just like those are the drugs are non-curable drugs like the cancer drugs, anti-cancer drugs, or for the diabetes patient. Every day they have to take the drug. So for avoid that purpose, what we can do is we can have the is incorporate the drug in the polymer, and by incorporating the drug into the polymer, it can kept into the patient. And once the drug is kept into the patient, that with the help with the change of the pH, the drug will slowly get released because we know the drug can get work only in the therapeutic range and instead of taking the higher dose, because when we go to the doctor give the prescription, take the medicine daily or the twice a day, thrice a day, so that for maintaining the therapeutic range that can be done. So that is what the innovations can be done. Well, but with these advantages, actually there are a lot of challenges in case of the this advanced polymers. So main thing is the cost and the production scalability, recycling, the environment impact. So with this background, I will discuss the two type of the high performance polymers. One is high performance and other is a for conducting application. That is what I have synthesized in my laboratory. So you have synthesized the various polymers like polyether ether ketones, polyamides, polyamides, and those polymers can be used for the different purpose. So high performance polymers, they have very high demand. These polymers because they have the very high dimensional stability. They can be used for the different applications. Means those polymers, those withstand thousands of hours at 230 degree centigrade temperature, 100 of hours at 300 degree centigrade temperature, minutes at 550, 540, and the seconds up to 760. So these are the general definition of the high performance polymers is made. So these high performance polymers, we can have the different type of these high performance polymers. So we'll today focus how to architect the monomer molecule, because this is okay, all this background this is okay, but when we go into the laboratory, once we enter into the laboratory, we have to design the molecule, because basic thing as a chemist, as a polymer chemist, the first thing is the design of the molecule. Once we design the molecule, then we can make the monomer, then that monomer can make the polymerization, and after the polymerization, then we can have the testing of the properties. So first thing is how to design the molecule. So again, there are the few thumb rules in case of the chemistry, in case of the polymer chemistry. So we know when we insert the flexible spacers into the polymer chain, then the polymer can become flexible. Because if we use only the aromatic rings, the polymer will become rod-like structure. But again, that polymer doesn't have the much applications. So when you go to use the application of the polymer should be soluble, it should be processable, because if you use only the polymer having the aromatic ring, that can have the very high temperature resistant. But at the same time, when we want to have the application of the polymer to make the different applications, that polymer material should be soluble and that should be processable. So we are making the processing by different processing techniques like injection, extrusion, blow molding. Those are for the simple aliphatic polymers. So for making any material out of the polymer, that polymer should be processable. So for making the polymer soluble and processable, we have to use the different approaches. So generally what we do, we insert the flexible linkages, or you can go for the Kang structures, or you can have the some pendant groups on the polymer. So if you put the pendant groups, flexible linkages, so automatically those polymers will become the useful one. So as a case study, I will show one for the polyamide. So for the polyamide, so this is how the monomer is synthesized. But behind the synthesis of this monomer, lot more efforts we have to take. So what now just we have discussed in the earlier approach. So we have to go to introduce the flexible linkage. So in this structure, you can find out in the structure 5, I introduce the CH2 linkage, the flexible. Again, for increase the thermal stability, we should have the aromatic rings. So aromatic rings has been introduced. At the same time, the two phenyl rings are the pendant type. So because of the pendant, that will become soluble. Aromatic ring that have the thermal stability. At the same time, again it can have the good solubility. So this is what is done with the tetraphenyl thiophene. So just we have the benzyl chloride, that with the sulfur and replace we are getting the tetraphenyl thiophene, and that again the acylation reaction, and then sulfur morpholin and morpholide, and then Bilgaro reaction we are getting the diacid. So this is how we prepare actually the monomer, and this monomer we allow to make the polymerization. So we are reacting with the different diamines, and with the reacting with the different diamines, we can get the polyamide. Now this polymer is a high performance polymer. We can have the simple polymer, or we can have the copolymer. Just we have discussed initially. We can have the, if you use the two same monomer is homopolymer. If you use the two different monomers, that become the copolymer. So we have the one diamine is oxydianiline. This is another one. So we can have this diacid CH2 diacid and this diacid. So by using the two different acids, we can make the copolymer. Again, the purpose of making the copolymer, they can become soluble. Again, in the chemistry, whatever the product we synthesize in the laboratory, that must be characterized. Again, it's not only you can talk like I have synthesized this one, likewise, nothing the case. Everything we have to prove it with the different characterization techniques, and whatever the product we have synthesized, that should be match the values. So for that purpose, with what we have done, just we have synthesized this monomer. After synthesis of this monomer, we have prepared the polymer, and this polymers we have characterized. So this is just for your information. This is one of the FTIR, and it shows the different peaks values are shown. So those peaks and values are relating to the polymer. That is what we are showing here. Again, we can have this TGA, thermal stability. So this polymer shows very good thermal resistance. Again, we have recorded the XRD that shows amorphous in the nature. So because this polymer is amorphous in the nature, so it has the good solubility, good thermal stability. So what we aim for getting the polymer which have the thermally stable polymer, so that we have achieved with this one. This is another example. That is how we do in our laboratory. So just like tetraphenyl thiophene, this is another molecule. That is how we have synthesized with the simple starting material like phenol and the cyclohexanone. So we are starting with the simple phenol and cyclohexanone. So we have prepared the bisphenol. So simple this diol. This diol we are reacting with this another compound. So we have got this intermediate, and again like earlier we have reacted this one, so we have got the diacid. Now then earlier structure tetraphenyl thiophene is different. Now this structure is different, so we have this cardomoiety here, this cyclohexene cardomoiety. So because of the cardomoiety, it has the different properties of the polymer. So in when we use the polymers as advanced polymer material, this can show the different property than the earlier. So just like what we have shown earlier, we can make the characterization of these different intermediates, monomers. This is one of the H1 NMR. That is what earlier I have shown you the FTIR. This is the carbon 13 NMR. So again we have the different peaks. So DEPT. So in case of the DEPT, again we go for the compounds. The tertiary carbon atoms will get absent. Again the carbon CH and the CH2 will appear up and down side. So this is what DEPT shows here. So from this we confirm the things. Also we need to record the mass spectra to show the purity. And once we do this one, if all the results matches with the expected one, then we go for the polymerization. So once we go for the polymerization, again this we are doing the simple liquid polymerization, solution polycondensation polymerization. So with the solution polycondensation polymerization at around moderate temperature, 100 degrees centigrade temperature, we allow it to polymerize. So as we allow it to polymerize, so this is diacid again reacting with the different diamine. So if you see below, the 8 different diamines has been used. So you can see the short forms has been shown, and with this I have got this polymer structure. So this polymer structure is different than earlier. It shows the different properties because now this structure is having the cardomoiety as compared to tetraphenyl thiopene. This polymer shows better aromatic property. At the same time, this polymer has a good solubility, and because this polymer has a good solubility, and because of the good solubility property, this polymer can be used for the more applications, and the processing of this polymer can become easier than earlier one. But at the same time, because the tetraphenyl thiopene moiety has more thermal stability, so because thermal stability is more, so that polymer is a more thermally stable, but at the same time, the processing of that polymer is become limited. But here, the processing of the polymer can become the very easy. This is another type of the polymer. That is what we can synthesize is a polyimide. Now, what we have seen earlier in case of the polyamide is a different. This polyimide category of the polymer, these polymers are having the more thermal stability as compared to this one. So, as we have seen earlier in advanced polymer applications, we can use these polyimide polymers for the different applications. So, generally, these are sold in the market name Altum. So, these polymers are the having the good low dielectric constants. They have the good chemical resistance. Dimensional stability of the polymer is good. So they are using for the high temperature applications. We can use in the microelectronics or aviation or the separation or encapsulations or even for the adhesives for the molds. So we can use these polymers for the different applications. So in continuation with the what we have shown earlier, so with the cardomoiety, we can prepare the diamine. So once we have this diamine, now this we can make for the polyimide. Now this is a different polymerization technique. What we have seen earlier for the polyamide, that is different. Here is the imide linkage. So here you can see the idea, the cursor, that is what I am showing. It might be visible to you. So this is imide linkage. So we reacting this diamine with the dianhydride. So it forms the polyamic acid, and with the thermal cyclation, we convert it to the imide linkage. So as we are converting it to the imide linkage, so now this is the polyimide polymer. We can even this instead of thermal, we can go for the chemical cyclization. So we can prepare the different series of the polymers, and among these different series, then again we can find out whether which polymer is having the better property for this one, and then that polymer you can use for the further application. So this is what again, as I have told you earlier, we can have the characterization of this polymer, thermal stability of the polymer. So because these polymers are showing the good thermal stability, we have measured it by using the thermogravimetric analysis, or the glass rising temperature of the polymers can be measured by using this DSC, differential scanning calorimetry. With the second heating stage, we can go for that one. Second, we can go for the X-ray study, and by the X-ray study, these polymers are showing good properties and the application. Apart from this, polymers can be also used for the conducting application, and we all know for the polymers to be used for the conducting applications, the polymers require the specific structures. Generally, the commonly used polymers in the market as the conducting polymers are the polyaniline, polythiophene, polyacetylene, and the conducting polymers. These polymers are having the very high demand in the market because the conducting material what we are using are the metals, that means the aluminum, copper, or the different metals we use. All the polymers are insulator. The current they doesn't carry the current because there is no free electron to carry the current. But there are few polymers they can carry the current, and so for that purpose we need to specifically design the polymers where there can have the alternate double bonds. If the polymers has those alternate double bond with the flow of the electron to the pi electron, those polymers can carry the current. And after that, we can have the coating into this one, we can load the polymer with the nanoparticles, and by loading the polymer with the nanoparticles, again they can increase the conductivity. So this is one example of this one. So we have synthesized the dialdehyde monomer. So with the help of the dialdehyde monomer, this dialdehyde monomer, we are allowed it to polymerize, and with the polymerization of this dialdehyde monomer with the diamine, so we have got the polyazomethane. Now N double bond CH, again here we have the this double bonded structures. So with the help of these double bonds, these polymers can use for the different application. One of the application that I have shown here is gas sensing application. So simple schematic low cost gas sensor unit. This is what we use in the laboratory for testing this one. So we have used this for the different gases at 25 degrees centigrade temperature for the reducing gases like NO2, H2S, ammonia, chlorine, and we have purged with the volume, and we have checked the response of this polymer, and it shows for the NO2 this has the good response at 100 ppm, 50 ppm for this polymer. So select it of the polyazomethane film. So this is what we have done for these different gases, the chlorine, ammonia, H2S, NO2. So this is what we have shown here. How this one actually, if you go scientifically, what actually in this structure we have this O2, and because of this is how actually the polymer shows the gas sensing mechanism. Why actually this polymer shows gas sensitivity? So this shows the gas sensing mechanism because of this structure. So this is how we have designed this structure, and with this designing of the structure, it can show this application. So this we can use this for the as a source for the conjugated backbones, or even for the donor applications. So you can use this material in the different way. Okay, so this is another way how we can use the polymers for the conducting application. So for that purpose, we have prepared this tetraphenyl thiophene, and from this tetraphenyl thiophene, that is what I have shown you earlier in case of the polyamide. Now this monomer we have prepared in the different way, and with the help of the different way, so this monomer I have used for making the polymer. So we have prepared the different polymer from this one, and these polymers we have characterized. Even we have taken the FESM images of this polymer. So nanoparticles morphology that we have studied here. So you can see the dark zone, light zone. So here particle size around 166 nm we observe here. In FESM image you can see here are the contact angle of the polymer is shown here, and so electrochemical analysis. So we have done the CV curves for this one. So current density versus potential. So we have find out the CV curves, and from the this one we have find out that the electrical charges storage capacity of the polymers that we have recorded. So these polymers can use valuable materials for the different electrochemical parameters. Even the galvanic charging discharging study also we have done for the stability, the charging discharging study, and the stability study that we have done for this polymer. We have shown here this polymer A, B, and then these are the selected polymer among this one. You can see the color black, red, green. So this is what we have shown here. So they are the stability study. This we have shown here. These are the all the results are reproducible. So this GCD profiles shows near triangular characteristics that is ideal for the charging storage behavior. So this is what we are using for the supercapacitor applications or for the battery applications. So for that purpose, that is what we are using these polymers. So these polymers is what the code I have made for this one. So they can retain the 52% of the this one 82% in the initial specific capacitance and 1000 cycle, resulting excellent electron material for the supercapacitor applications. So this is how we have done in our laboratory. Almost whatever the work I have showing you here, that all the work I have published in the various reputed international journals having the very good impact factors. This all is done for the PhD degree of the various PhD students. So again, this is the another monomer having the diamine linkage here. So with the help of this diamine linkage and so many aromatic rings, sulfur linkage, so there is a exactly what I have told you earlier, having the exactly alternate double bond. That's what we have in the polyacetylene. So that characteristics of this monomer we are utilized for the application. So we have prepared the polyazomethane from this one, and so you can see the idea everywhere. Once we pass the current, because of the delocalization of the pi electron, this polymer can carry the current. At the same time, this we can have doping also, and with the doping we can have the better property. Again, from the XRD, we can have the idea these polymers are having the amorphous in the nature, and because they are amorphous in the nature, so they are soluble in the solvent, and because of the good solubility behavior, these polymers we can utilize for the various applications, and by utilizing making the different material from this one. So comparison study, we can have the having the polymers, they are having the good viscosity, so you can cast the films, and by casting the films they are soluble in the solvent, and the physical properties of the polymers are shown here. So just like earlier we have done the cyclic automatic study, so we have the with the CV curves, with the results are shown on the screen. You can have a look for this one, these results. So capacitance we have calculated by using this one. So how we have calculated this one? So we have used the one more NaOH electrode, and we can have the KOH and Na2SO for electrolytes we have used here. So GDC profile study, that is what we have done, the stability, and that is how we have measured for this novel polymer. So GDC profile study. So that is what we have shown here. So nearly they are triangular. So ideal for the charge storage behavior, you can check here. So with this one, they are ideal structures. So again, the maximum specific capacitance is obtained for the Pa2 polymer. Here we can have this structure Pa2. So from this we can have the idea. So this is the Pa2 polymer. So this Pa2 polymer. So this shows the PM2 polymer, PAM2 polymer. That's better properties. Optimize and capacitance is acquired for the redox thiophene quinine mighty. Again, we have done the EIS measurements for the this PAM2 polymer, and so with this EIS measurements, we observe the excellent agreement with the experimental and the stability data. So cyclic life or stability of the polymer for polyazomethane electrode, we have done at the 100 MUS study in the 1 molar NaOH for the 500 cycles, and that indicate the ultimate stability for the after the 500 cycles. So current curve is decreased up to 66% up to the 500 cycle, that indicating good cycle property for the electrode material for supercapacitor applications. So this is what actually the PAM2 polymer I can show you here. Okay, so this is a PAM2 polymer. So this is PAM2. This is a 50% polymer from the terphthalaldehyd and acetaldehyde. When you use the 50% of this terphthalaldehyd and 50% of this one is 100%, this one is 100%. But when you make the copolymer of the two different aldehydes in the 50% composition, so when you take in 50% composition, this polymer shows better property as compared to the homopolymer. So this is what these results are shown here. So for the PAM2, AM2, the results are better. So in conclusion of this topic, I can say of this today's talk, the advanced polymers are materials improving the performance and rate of the applications. We can have the emerging materials and the new manufacturing technologies like 3D paintings will continue to push the boundaries for the polymers for the new applications. Or we can have the what the ongoing research we are doing, we can use for the other applications in the future. So for sustainability or the functionality or the forefront materials. So I must thanks for all my research students who have been performing the works from the last 20 years. So thank you all for patient listening. And now we can post. The session is open for the questions.
Very nice presentation, sir. And I request participants to ask the questions. Participants can unmute their mic and ask the question.
Some of the participants have raised their hands, like Shripad sir, Satyashila madam, Firdos, Sayyid, Trupti, Patil. If anyone of you want to ask the question, you can ask.
Yes, anybody? Means by mistake they have clicked the button. Yes, anyone still? Sir, may I ask one question?
Sure, sir, sure.
So now we have all this discussion about the polymer preparation, synthesis method, and then the solubility, and based on that solubility, the processability and all that. Now, while processing, which methods are used to molding into the desired shape, desired article preparation for by using these polymers?
Actually, very good question. Is application oriented, Dr. Patil sir. So depend upon the different polymers, use the different processing units. So when you talk about initially, as we discussed earlier, so if you talk about the simple aliphatic polymers, commercial polymers, we use the depend upon the application like injection molding, extrusion molding, blow molding. Those are for the commercial polymers. But when we talk about the specific polymers, so we can have the different, make the different articles from this polymer. So you have the casting the polymer films or how the batteries. So for we are developing the prototypes for that one. We develop the design that shape, and then we can have the processing of those polymers. Either we can go by the melting the polymers, we can make it melt, or we can go for the solution casting. We can soluble in the solvent, we can cast the into it, and then we can evaporate the solvent. So by this way, either by the thermal way or by the chemical way, we can make the different shape out of the polymers that has desired for the different applications, sir.
Yes, sir. Yes, sir. Thank you very much. So any means based on the article, what to be prepared.
Yes, now if
We
you
have
want to
to
prepare
choose
the battery, now if you want to prepare the electrode, so we can know the shape of the electrode, what type of electrode we want to prepare. So we can design that mold accordingly, and then we can have pour the polymer into that one, and then we can cast it the electrode or the have the battery, flexible battery. So accordingly, just to have the processing applications.
and there are very delicate many articles are there, very small articles are there. For small articles or very delicate articles, which method is preferable?
Again, depend upon the application of that material, whether it's delicate material or whatever. Now, simple, if you want to have the plastic chairs, plastic tables, we use the injection molding. For the PVC pipes, we go for the extrusion molding. Similarly, for the different, we have the different molds. So it depends what material we want to prepare or the casting we want to do.
Okay, sir. Okay. So, what is the scope for the biodegradable anything? Because the peoples are very means people use plastic, people use polymer, but the environment, people's environment point of view, many people's raise the finger towards polymer or plastic metal only.
Yes, again, it's very good question, because those are the all we love the environment. No one want to destroy our environment, but people are blaming for the plastic. Again, the plastic, what the people are blamed is only for the polyethylene. Apart from polyethylene, no one is blamed for others. So people mostly blame for the carry bags. So if you go for the biodegradable polymers, they can degrade on their own, and there is no environmental issue. But if you go for the alternative material for the polyethylene, we can have the alternative material, but still again, those materials are not cost effective. So we can use the polymers just like polylactic acid. We can have the polymers from the corn. We can have the polymers from the cashew nut cell liquid. We can have the polymers from the different renewable resources. So those polymers we can use. But only the problems the people are talking about the polyethylene. So just we have to restrict ourselves for use of the polyethylene carry bags, or we can make it proper use and then collecting the waste, because the policies of the government that doesn't attract the people to collect the plastic waste, because just in between I've told that you will never find any waste of the plastic bottles, because all the rack pickers, they are picking the plastic bottles, because everything is done to gain the money. So if the person pick the carry bag for a full day, he will not get more than 10 to 20 rupees. And on the contrary, if they go for collect the plastic bottles, they get more money. So if the policies are more likewise to have the collecting the carry bags, those are the lightweight plastics, those are flying in the environment. And if the government gives the more money to those people, automatically people will engage in picking that one, and you will find that the pollution get slightly decreased by this way. Again, this is one of the way, means this way, but again the government has the idea has the ban the carry bags. Those are having the less than 50 micron, but still again illegally people are using this one, and because of that only there is a problem, because whatever the carry bags authorized by the government are recyclable, so they should not have the problem about the pollution.
Yes, sir. Yes, sir. So, just out of the society point of view, to give the message regarding the polymer in the society among the participants who are not connected with the means polymer chemistry, I have asked this question actually.
Yes.
Yeah. So through this FDP, we can give message in the society, because nobody can live without plastic. Right from the early in the morning when we wake up to till sleep, we have to be with the polymer material. Without polymer material, now the life is impossible. And still, the peoples are blamed on polymer. That's why we should stress on this point. So thank you for the guidance, sir. Is there anybody?
Yes, sir.
Still
Gaurav
want to ask-
Deshpande, sir, has raised his hand. Do you have any questions, sir? Gaurav, sir? Gaurav Deshpande?
hand raise people's, I don't know whether they are raising the hands by mistake or what.
No, sir. No, sir. It's by mistake.
Okay.
Okay, so anyone still? I request the participants to make on your video. Make on your video. We will take a screenshot. The expert is with us. The expert is with us in presence of resource person. We will take one photo. I request the participants to make on your camera. Make on your camera so that we can have one photo screenshot of this final session, because till now we have completed 12 sessions, but occasionally anyone has camera is not getting on. Shelar sir, please allow everyone to
Yes,
make the
sir.
camera.
Yes. Just a minute, sir.
Yes.
Yes. Yes.
Because host people are only can make the.
Yes, it's on, sir, now. I'm able to see
That's very
all.
nice. Yes, that's very nice. So, Shalar sir, please
Just
take the.
give, yes, yes. Just give me 2 minutes, sir. I'll take screenshot.
Yes, sir. Yes. So nice to see everyone. We had these 6 days. I hope you all enjoyed and also get the knowledge of material, varieties of materials. So we will take the feedback, video feedback also during the valedictory session, which will follow immediately.
It's done, sir.
Yes, sir. Sir, will you try on mobile also? Because we can scroll another other people's also other screen also.
Yes, yes.
So I take this opportunity to thank Dr. Ghanwat. Uh, he's a resource person. He's working with university since inception of the university. He's having lot of experience in administration, developing university, various bodies. He is working in various bodies of the university. So such a person we uh, got in our last session, and I take this opportunity to request sir to be the chief guest for the valedictory function. What we have to continue immediately. So we will follow with the valedictory session.
Sure, sir. I should thankful to the Professor Maldar sir because he has taught me everything. So since from my student days to till today, he's always guiding me on everything. So whatever the research I have done or the responsibilities I have held, it is only because of the Professor Maldar sir. He was my PhD mentor, and for shaping my life, he is the most responsible person. So for that purpose, I thank Professor Maldar sir for this one, and also for you.
Coincidentally, Maldar sir, Dr. N. Maldar, the former Vice Chancellor of Solapur University, was the inaugural function chief guest, and his student, Dr. Anil Ghanwat, is the chief guest for the valedictory function. And I also want to uh, say here, I am the also student of Dr. N. Maldar. Under his guidance, I have completed my PhD. So thank you from my side also to Dr. N. Maldar sir. He's there with us now also.
Huh?
And
Is it?
all many sessions out of 13 sessions he had joined whenever polymer and related material and out of his interest the subjects come, he used to join the meeting and used to guide the participants as well the resource persons also. Thank you very much, sir. Here with I conclude this session. Conclude this session.
Thank you
Sheila,
very much.
yes,
Thank you,
sir.
sir.
Yes.
Okay, then bye. See you.
Thank you, sir. Thank you.
I am out of Mumbai, so
Yes, sir. Yes, sir.
Good evening, sir.
okay then. Okay, see you sometime.
Yes,
All
sir.
the
Our,
best.
our
Thank you,
principal
sir.
is
Thank
there,
you.
sir.
Plan some other places.
Yes, sir.
Okay,
Sir.
sir. Thank you.
Our
Okay.
principal Chavan sir is also there.
Yes, sir.
See you then sometime. Take
Yes,
care.
sir. Yes. Thank you, sir. Thank you.
Good evening, sir. Maldar sir, good evening.
Okay, namaskar.
नमस्कार सर.
फार छान झाला कार्यक्रम. I enjoyed everything.
येस येस, तुमच्या सगळ्यांचे आशीर्वाद आणि तुमच्या शुभेच्छा
पुन्हा भेटू पुन्हा एकदा कधीतरी आल्यानंतर. ओके
याच
देन.
एरियामध्ये तुम्ही म्हणजे असल्यामुळे हे सेशन छान झालेलंच आहे.
तर तुम्ही बंद करतो कारण मला दुसरं जायचं आता एका ठिकाणी.
We'll invite you,
Okay,
sir.
then.
Yes, sir.
Okay, sir.
ओके बाय.
Thank
Good
you.
day.
Thank you, sir. Thank you. Thank you, sir.
Okay. Shelar sir, recording
Yes,
of
yes,
this
sir.
session we will
I've-
stop and again recontinue
Yes, sir.
as a validatory session.
Yes, participants can close their video, sir. No.
Yeah.
I've taken the screenshots. Yes.
Yes.
Thank you, sir. Thank you.
Yes. Don't leave the meeting. Participants, don't leave the meeting. And our validatory session will commence immediately. And after validity session, you have to give online test on Atal portal in your login. And I have posted the flow of assessment, how to do that assignment, how to give that online